For standard 10th, we'll continue problems on matrix multiplication, which will include the scalar multiplication as well as matrix multiplication. I've written 3 questions on the board. In the first question, I have A, the matrix A is 1, minus 1, minus 2, minus 2. It is 2 by 2 matrix. 2 rows, 2 columns. B is 4, 5, 3, 3 and C is 2, 7, 1, 5. What I need to show is AB is equal to AC. That means I have to multiply the matrix A and B, and I have to multiply A and C and see whether they are equal or not. So let us take first of all find out A and B. Matrix multiplication A and B is possible because both are a square matrix of the same order, 2 into 2, because the condition for matrix multiplication is that number of columns in matrix A should be equal to number of rows in matrix B. It is because number of rows and number of columns are both same in these both matrices, so matrix multiplication is possible. A is 1, 1, minus 2, 2, minus 2, and 4, 5, 3, 3. 4, 5, 3, 3. We told you how do we multiply. We told you that how do we multiply the two matrices. We told you how do we multiply two matrix. The method of multiplication is, it is not minus 2, it is 2 only. The method of matrix multiplication is that we will multiply the elements of the first row of the first matrix with the first column of the second matrix. I had explained to you in earlier video, completely taking 4 steps, that how do we calculate the elements. Here, but even then I'll take my time so that you understand. 1 into 4, first element of this matrix with the first element of this matrix, plus 1 into 3. So we have multiplied the elements of the first row of the first column, matrix with the first column of the second matrix. 1 into 4 plus 1 into 3. Then the same row, that is the first row of the first matrix, will be multiplied by the second column of the second matrix. That is 1 into 5 plus 1 into 3. First row into first column, then first row into second column. Now the same process will be repeated with the second row. Second row, first column. That is 2 into 4 minus 2 into 3. The first element of the second row will be multiplied by the first element of the first column. Then minus 2 into 3. Then 2 into 5 minus 2 into 3. 2 into 5 minus 2 into 3. First row into first column, first row into second column, then second row into first column, and second row into second column. That is how we are going to obtain the matrix. 1 into 4 is 4, 3 into 1 is 3, so 4 plus 3 will be 7. So we get the first element as 7. 1 into 5 is 5, plus 1 into 3 is 3, so 5 plus 3 is 8. Then 2 4s are 8, 2 3s are 6, and there is negative sign in between, so 8 minus 6 will be 2. 5 2s are 10, minus 6, 10 minus 6 is 4. So A into B comes out to be 7, 8, 2, 4. It comes out to be 7, 8, 2, 4. It comes out to be 7, 8, 2, 4. We have made a mistake here again. This is minus 1 here. This is minus 1, so we will have to change it. first row into first column, then minus, it will become minus here. Minus 1 into 3. 1 into 5 into minus 1 into 3. Then 2 into 4 is okay. Then minus 2 into 3 is okay. 2 into 5 is okay. Minus 2 into 3. While picking up this matrix from here to here, we made a mistake. This mistake is quite possible by you also during examination. You have to be careful. 1 into 4, 4 minus 3 is 1 here. And 5 minus 3 is 2 here. So 1, 2, 2, 4. 1, 2, 2, 4. Now let us see matrix AC. Second one is A into C. Let us see what is A. A is 1 minus 1, 2 minus 2. 1 minus 1, 2 minus 2. And C is 2, 7, 1, 5. 2, 7, 1, 5. 2, 7, 1, 5. 2, 7, 1, 5. Let us multiply them again. First row into first column. So 1 into 2 minus 1 into 1. Then 1 into 7 minus 1 into 5. 2 into 2 minus 2 into 1. 2 into 7 minus 2 into 5. Let us see what do we get. 1 into 2 is 2, 2 minus 1 is 1. So this is okay, 1 is okay. 1 into 7 minus 1 into 5. 7 minus 5 is 2, so this is okay. The first row is coming same. 2 2s are 4 minus 2, that is 2 again. This is okay, this is same. 2 7s are 14 minus 10. 14 minus 10 is 4, so it is the same. So that means the matrix AB is equal to AC. So AB is equal to AC. That's what we had to prove in this matrix multiplication. It is simple matrix multiplication. Again, first row into first column. We pick up this element 1 multiplied by 2. Second element is multiplied by the second. Whichever you are considering. I am taking first row. So I'll pick up the first element of the first row, multiply by the first element of the first column. It will be first row also, first column also. Then the second element of the first row with the second element of the first column. First row, first column. First row, second column. Second row, first column. Second row, second column. So by multiplication we calculated AB, we calculated AC, and we found that AB is equal to AC. Now let us see question number 2. In question number 2, he has used trigonometric functions or as elements. Trigonometric ratios you can say as elements. Like he says, evaluate 2 cos 60 minus 2 sin 30 minus 1045 cos 0 cot 45 cosec 30 sec 60 and sine 90. Instead of using the usual elements like 1, 2, 3, 4 like we do it at matrix multiplication or matrix, he has used the trigonometric ratio. You know the values. Cos 60 The value of cos 60 is 1 upon 2. So 2 into 1 upon 2. Then minus 2 sine 30. 2 sine 30 is 1 upon 2. 1045 is 1. 0 is, cos 0 is 1. The value of cos 0 is 1. Cot 45 is 1. 1045 is 1. Cot 45 is 1. Cosec 30 is opposite of sine 30. It was 1 upon 2. So it will be 2. Sec 60 is opposite of cos 60. Cos 60 was 1 upon 2. So sec 60 will be 2. And sine 90 is 1. So first of all, we substituted all the values of the trigonometric ratios. 2 will cancel with 2, 2 will cancel with 2. So it will become 1, minus 1, minus 1, 1. This matrix, the first one. And second one is 1, 2, 2, 1. Let us multiply. First row into first column. First row into first column. First row into second column, second row into first column, second row into second column. Let us see here. 1 into 1 minus 1 into 2. 1 into 1 minus 1 into 2. 1 into 2 minus 1 into 1 minus 1 into 1 plus 1 into 2 minus 1 into 2 plus 1 into 1. First row into first column, first row into second column, second row into first column, second row into second column. That is how we multiply, and let us see the value. 1 into 1 is 1, 1 minus 2 is minus 1. 1 into 2 is 2, 2 minus 1 is 1. Minus 1 plus 2 is 1. Minus 1 into 2 is minus 2, minus 2 plus 1 is minus 1. So we get the matrix minus 1, 1, 1 minus 1. You need to know, remember the values of cos 60, sin 30, 1045, cos 0, cot 45, cosec 60, cosec 30, sec 60 and sin 90 from your special angle tables. We had made it, but by this time you should be able to remember. You don't have to worry about the table every time. If you remember the value of sine, even if you remember the value of sine, every value can be remembered and calculated. It is important because if you don't know these values, you cannot calculate the matrix. So it is important that you have the values of cos 60, sin 30, and he said do not use tables. We cannot use tables, logarithmic tables here. Okay, let's see the third question now. The third question is, he has given you A, B, C and D, 4 matrices are given. He wants you to evaluate AB plus 2C minus 4D. Let us first of all write down A and B. A is 3 minus 2 minus 1, 4. And B is 6 and 1. Now these matrices are not of the same order. So we'll have to find out, first of all, see whether multiplication A into B is possible or not. The order of this matrix is 2 into 2, number of rows into number of column. Number of rows into number of column, 2 into 1. So this is the order of the matrix here, this is the order of the matrix here. Now for matrix multiplication A and B to happen, the number of columns in A, which are 2, should be equal to number of rows in B. So number of columns in A are 2 and number of rows in B are 2. So that is why the matrix multiplication is possible. This is 2 here and this is 2 here. So it is possible. It is possible. Now let us see whether BA is possible or not. How many columns are there in B? 1. It has got 1 column. And how many rows are there in A? 2. So number of columns is not equal to number of rows in B. So BA is not possible. AB is possible. BA not possible. Because the number of columns in the first matrix should be equal to number of rows in the second matrix. Then only matrix multiplication is possible, and this problem arises only when they are not of the same order, where they are not of the same order. But here AB is possible, and you will see why. First row into first column. First row into first column, that is 3 into 6 minus 2 into 1. First row, first column. That's what the way is. First row into first column. Then second row into first column. That is minus 1 into 6 plus 4 into 1. So it will come 18 minus 2 and minus 6 plus 4. So 18 minus 2 is 16 and minus 2. So you have the matrix AB as 16 minus 2. The matrix AB is 16 minus 2. Now let us calculate 2C. Let us calculate 2C. 2C is simple scalar multiplication. C will be multiplied by 2. The scalar 2. That is 2 4s are 8, 2 5s are 10. So I get 2C. Then I want to get 4D. Again 4D is a scalar multiplication. 4 into D. 4 and the matrix D is 2, 2. So it will become 8 and 8. Now you have to get AB plus 2C minus 4D. AB plus 2C minus 4D. We have calculated everything individually. The matrix AB is 16 minus 2 plus 2C I have calculated as minus 8, 10, and this is minus 4D. So minus 8, 8. Now 16 plus minus 8. 16 minus 8 will be minus 8. And minus 8 will be minus 16. Minus 16. Here it is minus 2 plus 10. Minus 2 plus 10 is 8. 8 minus 8 is 0. So you have the matrix like this. You have the matrix like this. That is 16, no, it is 0. 16 minus 8 is 0. 16 minus 8 and it is also minus 8, so it is 0. It is 16 and it is minus 16. So 16 minus 16 is 0. So 0, 0 will be your matrix. Okay, the next question for matrix multiplication is, he is asking you to calculate x and y in this. He is asking you the value of x and y in this. Like we have x, 3x, y, 4y, 2, 1 is equal to 5, 12. First of all, we have to see, obviously matrix multiplication will be possible because he has given you an equation. But even then, number of columns in this matrix are 2. xy is one column, 3x, 4y is another column. Number of columns should be equal to number of rows in the second matrix. In this, 2 is the one row and 1 is another row. So matrix multiplication from this to this is possible. If I multiply this matrix with this matrix, I'll get x into 2 is 2x plus 3x. 3x into 1 is 3x. Then y into 2 is 2y and plus 4y is equal to 5 and 12. We told you the equality of the matrix, that two matrices can be only equal if their corresponding elements are equal. So 2x plus 3x is 5x. 5x will be equal to 5. That will imply x is equal to 1. The value of x comes out to be 1. Now 2y plus 4y is 6y. 6y is 12. So y will be 2. The value of y will be 2. We have got the value of x. We have got the value of y. Okay. Question number 5 in this is, he says A is matrix. It is given, the matrix A is 2 minus 3 P Q. A is 2 minus 3 PQ, and he says find P and Q if A square is equal to I. A square is equal to I. I means identity matrix. I is a unit or identity matrix. So first of all, let me calculate A square. A square means A into A. A square means A into A. 2 minus 3 PQ, and again 2 minus 3 PQ. Both are the same matrix of the order 2 into 2 square matrix. That is why matrix multiplication is possible. Number of columns are 2, number of rows are 2. That is why matrix multiplication is possible. It will be 2 into 2, 4, minus 3p. 2 into minus 3 is minus 6, minus 3q. P into 2 is 2p plus pq. P into minus 3 is minus 3p plus q square. Q into q is q square. And he says A should be equal to I square. Sorry, A square should be equal to I. I means unit matrix in which the principal diagonal or the principal diagonal which is start from top left to the bottom right should be unit, and the remaining element should be 0, and it has to be a square matrix. It has to be a square matrix because it is matrix of the order 2 into 2, so unit matrix will be taken of the order 2 into 2 only. Now let us equate. If the two matrices are equal, then they will be only equal if their corresponding elements are equal. So 4 minus 3p is equal to 1. 4 minus 3p is equal to 1 will imply minus 3p is equal to minus 3. 1 minus 4 will be minus 3 will imply p is equal to 1. We've got the value of p as 1. Second one is 6 minus 3q is equal to 0. That will imply minus 3q is equal to 6, or that will imply q is equal to minus 2. We have to calculate the value of p and q only. So I don't need to solve actually these two second equations, because I needed the value of p and q, which I have calculated. But if you put the value of p and q in these two equations, they will satisfy this. Value of p is 1, so 2 into 1 will be, look at this element, 2p plus pq. 2 into 1 will become 2. P is 1 and q is minus 2. So 2 minus 2 will be equal to 0, which is 0. Let us see the second one, minus 3p plus q square. Q is 1, so minus 3. And what is the value of minus 3 into P? Minus 3 into P is minus 3, and Q square is minus 4 plus 4. So 4 minus 3 will be 1, which is the element here. So that means P and Q satisfy all the 4. P and Q satisfy all the 4. Though I don't need to show them, I need to calculate only value of P and Q. So take the first two equal terms, put them equal, get the value of P and Q. You don't need to bother even about these things. Thank you.